Chapter 1. Hackers Test 1 to 5.
Listen to a conversation between a student and a professor.
Hi, Professor Jennings. I hope I'm not bothering you.
It's, Sally, right?
Right. I'm really struggling with my presentation topic. It's the law of diminishing returns.
I'm not surprised. It's a complex concept. That's why I gave everyone a list of supplemental readings. You read those articles, right?
Of course, but I still feel a little lost. I was hoping you could go over it with me.
Okay, I provided a basic definition of this economic principle in class. Do you remember what it was?
Well, the law of diminishing returns has to do with, the factors of production.
Right, and these can be almost anything. It depends on the circumstances. In the case of a farm, seeds, land, and fertilizer are the factors of production. But in, say, a factory, you'd be dealing with something else. Go on.
Let me think. Okay, when only one factor is increased, the others remain constant. Then, well, at a certain point, production will decrease. But that's what confuses me. I don't really understand why this would lead to lower overall output.
I see the problem. You're confused about a key element of this law. Just to be clear, increasing only one factor will not cause overall output to decline. It will rise. But each time you do this, the resulting increase in production will be smaller. Eventually, the extra output will not be worth the cost of the additional input.
I guess that makes sense. But still, it's just so abstract. I'm having trouble understanding what it means in practical terms.
Well, let's look at an example then. Imagine that you are in charge of the university cafeteria. If the number of customers increased, how would you deal with it?
Bring in more workers, I suppose.
That's what most people would do. And it would initially result in a significant boost in production. More workers means more meals. Now, say you just kept adding new employees, and you didn't install new kitchen equipment or, purchase larger quantities of ingredients. You only increased one factor of production. In other words, what do you think would happen?
The workers would probably slow down a bit.
Exactly. Workers would be wasting a lot of time. Getting in each other's way and so on. Overall output would continue to increase a bit as new workers were added, but not enough to justify their wages. Does that make sense?
I think I have a lot of work to do for my presentation. This is really complicated.
Well, there might be some good resources online, and I can recommend a few books for you that should be available at the library.
That would be very helpful.
Oh, I almost forgot. Professor Wilkins has written several articles on this topic. Maybe you could ask him about other sources of information. I'm sure he'd be glad to help.
Thanks. I'll do that now.
Now get ready to answer the questions. You may use your notes to help you answer.
1. Why does the student go to see the professor? 2. What does the professor say about the factors of production? 3. According to the professor, what is an important aspect of the law of diminishing returns?
Listen again to part of the conversation. Then answer the question.
Overall output would continue to increase a bit as new workers were added, but not enough to justify their wages. Does that make sense?
I think I have a lot of work to do for my presentation. This is really complicated.
4. What does the student mean when she says this?
I think I have a lot of work to do for my presentation.
Five. The professor suggests several ways for the student to learn more about a law of economics. Indicate whether each of the following is included. Six to 11. Listen to part of a lecture in a sociology class.
This week, we're looking at urbanization models, theories that explain the internal structures of cities. You've already learned about the ring model proposed by Ernest Burgess from the assigned reading, but there are a couple of more recent ones I'd like to consider. So, as the reading explained, the ring model divides a city into 5 ring-shaped areas with a central business district, or CBD, in the middle. The 2 rings closest to the center include factories and businesses. The other 3 rings are made up of homes. And these homes are more expensive the further away you get from the CBD. Well, this model was criticized because it didn't match how cities are really organized. This led Homer Hoyt to develop the sector model. Now, Hoyt agreed with Burgess about the CBD, but he argued that the rest of a city doesn't fit into these neat, ring-shaped patterns. Instead, cities include irregularly shaped areas called sectors. In Hoyt's model, industrial, commercial, and residential areas form separate sectors, and the locations of these sectors are determined by the city's transportation routes.
I get it. If I owned a factory, then, well, I'd want my business to be near a major road or something so I could move my goods more easily.
Yes, that's a perfect example. And this is how Hoyt explained the urbanization process. First, major transportation routes, roads and railway lines, are built extending from the city center. Then the industrial areas form along these. Finally, the development of residential areas is determined by where these factories have been built. Working-class neighborhoods are found on the edges of the industrial sectors. Wealthier neighborhoods are located as far as possible from the factories.
So what I'm hearing is, according to Hoyt, a city is organized like a sliced pie? Is that right? The different sectors kind of extend from the CBD like knife marks in a pie?
Well, the sectors aren't uniform in shape or size, but that's the general idea. However, some people felt that Hoyt's model didn't describe actual cities any better than the ring model. They argued that the problem was that Hoyt placed too much of an emphasis on the CBD. He thought that the CBD was the focal point of the entire city. To address this issue, Chancey Harris and Edward Ullman proposed the multiple nuclei model.
Nuclei? Isn't that the middle part of, a cell?
Right. And that's how Harris and Ullman viewed a city, as a collection of distinct areas that form around key institutions, the nuclei, in other words. They argued that cities have many centers, each with a different function, and the centers develop independently of the CBD, so they can be located almost anywhere in a city. Okay, I can see some blank looks out there. Take our university, for example. What's nearby?
Coffee shops, bookstores, lots of cheap restaurants, things like that.
Good. These are places that provide students with what they need. The university is the basis of this entire area of the city. Certain types of businesses are attracted to the area because of the university, while others stay away. And this happens everywhere in the city. And, of course, the types of businesses in these centers determine what kinds of residential neighborhoods form nearby. So, the main benefit of the multiple nuclei model is its flexibility. Unlike the others we've discussed, this way of describing the process of urbanization can be applied to any city.
Now get ready to answer the questions. You may use your notes to help you answer.
6. What is the lecture mainly about? Seven. What does the professor say about the ring model? Eight. In the lecture, the professor explains the steps in the urbanization process according to Hoyt. Put the steps listed below in the correct order. Listen again to part of the lecture. Then answer the question.
So what I'm hearing is, according to Hoyt, a city is organized like a sliced pie? Is that right? The different sectors kind of extend from the CBD like knife marks in a pie?
Well, the sectors aren't uniform in shape or size, but that's the general idea.
9. What does the student mean when he says this?
So what I'm hearing is,
"10. What are key elements of the multiple nuclei model? 11. According to the professor, what is an advantage of the multiple nuclei model? (12 to 17). Listen to part of a lecture in a geology class.
By now, the role of vegetation in keeping the banks of rivers stable should be pretty clear. Without plants, specifically without their roots to hold the soil around rivers in place, most rivers wouldn't stay on fixed paths. But it's important to note that there are a number of natural events that can alter the shape of a river, such as flooding. For the rest of the class, we're going to look at this more closely. A flood occurs when a river overflows its banks. In other words, the water rises so high that it spills out over the sides. This normally happens when too much water enters the river. How often this occurs is determined by a couple of factors. One is whether a region experiences significant rises in precipitation at different points in the year, like spring or summer. Another is the type of rock and soil found in the land around a river. If this material can absorb a lot of water, well, then floods are less common. If not, the risk of floods is high. So, how do floods affect the shape of a river? Of course, when the water overflows, the river becomes wider. But this is just a temporary change. However, floods can also alter the river system permanently. For example, a river channel can become deeper over time. Does anyone know why this happens?
Well, the water moves more quickly during a flood, right? So maybe maybe it digs out the bottom of the river?
I can see how that would make sense, but, well,
it's not what happens.
In fact, a river channel gets deeper because sediments are deposited around it. You see, whenever a river overflows, it leaves soil and rock on the land beside it. Each time this happens, the land on either side of the river becomes a little higher. These raised areas of land are called levees. In extreme cases, the sides of the river can become significantly higher than the surrounding land, and this means that the river channel is much deeper. Now, do you have a question?
Do the levees ever get high enough to actually prevent flooding?
They can, in fact. Sometimes years can pass without a flood happening. But if there's an unusually large amount of snow or rain one year, well, it's almost as if the levee doesn't exist. The water just goes right over it. In some cases, the force of the moving water can also destroy these natural barriers. Now, if a region regularly experiences such massive floods, well, the appearance of the river can change dramatically. The Jamuna River in Bangladesh is a good example of this phenomenon. I've researched this river system extensively, and it's fascinating. There's always something new to observe. Take a look at this picture. What's the first thing you notice?
It seems like a bunch of individual streams rather than one big river.
Good. That's because repeated flooding has caused many new channels to form. The river floods seasonally. You see, as the excess water moves downstream, it carries large amounts of sediment. This leads to the creation of islands that split up the river into different streams. You should note that these islands aren't necessarily permanent. Some increase in size every year, while others are destroyed by subsequent floods. In addition, the floodwaters can break down the riverbanks, creating new paths for the water to follow. The end result is a complex network of connected waterways.
Now get ready to answer the questions. You may use your notes to help you answer.
12. What is the main topic of the lecture? 13. What are the factors that determine the frequency of floods in a river system? (14) What happens during flooding to cause a river channel to become deeper? Listen again to part of the lecture. Then answer the question.
Do the levees ever get high enough to actually prevent flooding?
They can, in fact. Sometimes years can pass without a flood happening. But if there's an unusually large amount of snow or rain one year, well, it's almost as if the levee doesn't exist. The water just goes right over it.
15. What does the professor mean when she says this?
Well, it's almost as if the levee doesn't exist.
(16) What is the professor's opinion of the Jamuna River? (17) In the lecture, the professor describes several characteristics of the Jamuna River. Indicate whether each of the following is a characteristic.